everyone and welcome into yet another live stream, and today we will be mostly researching chemistry. Yeah, that's mostly like what we'll do, but also render stuff and animate some geometry nodes action. That would be exciting, maybe even record something. We can do stuff. Okay, hold on, let me first open up everything. There we go. That's mostly everything open up. Okay. So I've rendered everything up to integrals at this point. Look at this. That's where we are. Explaining what integrals mean in the video. Everything is rendered up to this point. And you know what? I still have not finished the Fourier transform segment. That's mainly because I have been looking for other videos to work on in the background, and whilst looking for other videos to work on, there we go, I just got distracted and I haven't finished the Fourier transform segment, which will be a problem soon because we're not that far from it. Okay, right now I have finished everything up to. Ooh, we should change it up a bit. Should we? Right here. Actually, let's simplify for the sake of example. Like so, and the reason why is because this actually, I don't know how to do the animation I want to do. Or this function will be a bit too complex for my abilities, that's why instead we'll need to change it up a bit, and I really hope 30 will be good enough. No wait, 330, there we go. And I really hope that Animal can work on curves, because if not, okay, insert key, right. I don't remember how to. Another thing I just. Oh, damn it. Ah, shucks. Okay. It's fine. I can make it happen. All I need to do is just flatten it. Non-visual only medium point. Flatten it to 0. Lower it down. And now we just need negative x squared plus 3? How about that? How about that? Negative x squared plus 3. If I do remember correctly, the distance between each of these points is 1. At least that's how we can treat it, which means 3, 4, 3.5. Okay, so the function we'll go for will be. Actually, no, because then now when we move these two up, then this will also. Okay, so the function we'll go for will be negative x squared plus 3, which means both of these will. That's a no wait, that's a 0. Negative x squared plus 2, right? Which means both of these will go for 1. Damn it. I don't want to do the function like this because that wouldn't be the easiest. I mean, I can, I guess. What's the name of it? Oh, what's the name of... There was a normal distribution. Was e to the negative x power. It was normal distribution. Would you look at that? Okay. Yeah, okay. E to the negative x squared divided by 2. Well, we don't have to divide it. E to the negative x squared. For which we will very much need. Okay, thank goodness. Alright, so it is keyframed. That's good. That's good at least. This will be our 0 point. 0 level. Now what we need is we need to apply the function. Alright. Desmos.com. I don't know why I looked up this way. I could have just typed in. Okay. So, e to the negative x squared. I'm pretty certain we should be able to do it in Blender, I think. I think that's a function we can achieve, okay. So, we might have to do it times 2, because... Yeah, let's do it times 2. Alright. F of x is equal to this. And now f of 0 is a 2. Alright, sweet. F of 1... Hi the call, hi the Dyke, welcome. It's 3678. Okay. 0.3678 times 2. There we go. 2 is a 0. I'm really hoping the distance is accurate here. No, because this is a 1. Oh my goodness. Okay, no, so this is okay. So between each of them, it's a half. I'm fine. I can figure this out. 2. There we go. So both of these we want to go up by 0.3678 times 2. There we go. Now both of these need 0.7788007 times 2. There we go. Now we're getting somewhere. And then 0.0 0.05399 times 2. There we go. And now you at distance 2. 0.01831. Whoa, an integral, exactly. And that will by 2. Hi Decorium, welcome. And so there we go. Now we insert keys and... I'm such a professional. We can shorten this too. There we go. I'm just such a professional. New math video coming soon. Yeah, we soonish. And also a chemistry video. Oh wait, that's the wrong chemistry video. Yeah, music really amped up when I mentioned chemistry. This is what happens. Why advanced chemistry is... No wait, that's the wrong video too. Right video. Oh no, why advanced chemistry is... No, this music is too much. There, much better. Why advanced chemistry is easier could be a good one. I really want to make a chemistry video. I haven't made one in a while. It's just upsetting me. The only problem is, I don't know where to research for this. And the chemistry for the first time and then I hate chemistry. I love chemistry. Chemistry is great. Absolutely love it. Statistical physics. No, we're gonna need to change all this completely. Now it's time for try number 7 of finding a chemistry textbook for the video that I'm looking for. Try number 7. Inorganic chemistry would be the nicest, I do believe. I guess any advanced inorganic chemistry will do. I just have to get into it. Introduction to organometallic. Not quite. No. Introduction to inorganic and inorganic. Sounds nice. Let's see. What's this one? Chemical bonding, molecular orbital theory, acid-base chemistry. These are all basic stuff. Basic science and nanometals. Okay, it ends not quite where I wanted to. This is all too basic. It pays off when you get to advanced biology courses. Yeah, but does it pay off to even try to get to advanced biology courses? Okay, this is a... maybe? No. Like, this would be fine for the first chapter, but that's kind of it. Otherwise, this is really way too basic. It's not quite what I'm looking for. Not quite what I'm looking for. Map in organic chemistry, what does that mean? Oh, going over each group. That's yeah, cool. Wouldn't be physical chemistry. It will be physical. Damn it. It's fun to learn though. I really like chemistry. Chemistry is great. Okay, what's the scope of physical chemistry again? Okay. That's a more of a maybe. That's a massive textbook though. Math chapter is 32. That's literal opposite of any quantum mechanics textbook. Like there are so many quantum mechanics textbooks where the Euler's identity is damaged for the first chapter. Ever like learning since early in my life? Yeah, I mean, although I need to stretch. Ah, there we go. It's fine if you only want to learn stuff you'll use in your life, but you do realize that what you learn will affect what you will do in your life, right? Like saying that you'll only learn something you'll do in your life, well, that's fine, but for example, if you want to learn, I don't know, calculus and integrals, right? On the surface, it doesn't really feel like that's something you would ever use. And I mean ever. Why would you ever use integrals in your normal day-to-day life? But the thing is, when you actually study integrals, when you actually get to know them, when you actually understand how they work, then you will find uses for them in your everyday life. Something uses which you would not be aware of if not for the fact that you've learned about them. I recently had a clogged drain. I used sulfuric acid to unclog it. Wouldn't recommend, by the way, to anyone. It's not a good idea to use acids. It was low concentration one. Usually, the shops were closed. Just that's the problem, and I wanted to unclog it immediately. Okay. Advanced theoretical. I don't like it because advanced will be really advanced. I know I've been over this already. 9 chapters? How big is this overview? That might be skewed. Electronic structure, for example. Acid to unclogged. It worked! I'm just saying. 10. But to be fair, it doesn't seem too awful. Well, let's give it a whack. Let's give it a whack and see. What's this doing? Barely in there. That's what she said. Okay. Why quantum mechanics is necessary? I can fathom a guess. Schrödinger equation and its components, been there than that, born Oppenheimer. I should still just gloss over the chapters. And also another important thing. How are we looking? Free to share, adapt, attribution, not to share, like, if you remake change of a bit of the distribution and the same license as original. Hell yeah, okay, been there done that. I use the bomb ticket, doesn't work with this type of stuff. It works! Hey! If something is dumb but it works, that means it's not dumb. It worked. Okay. That's the wrong page. There we go. I really shouldn't... yeah, I need the notes thing. Notes. Things and stuff. Okay, quantum mechanics. Yup, this is shells, right? Scattering. Not shells, the... slits. Cheesing and whatnot. Oh, scattering, I see. Well, we have been there. We have been there, done that. To be fair, it is in a different context than I normally present it, but check it out a bit stable. Okay. The electron perfectly conjugated in would counter Coulomb's force given by nucleus charge Z. The most American idea I've ever heard. No, Americans wouldn't use bombs. Americans would use guns. Only the Irish would use bombs. For freedom! Coulomb force except by nucleus charge. Okay. Makes sense. Perfectly countable, it was cool. It has to, of course. Yes. It has to counterbalance it. If I'm understanding it correctly. Of an orbit in terms of the radius of the orbit is this. Oh wait, this actually, oh, we're starting right, thank goodness I didn't skip it anything. We're starting right off with just the absolute banger of a chapter. This is an absolute banger. Bragg equations. Quit bragging about it. Okay. Wait, important observations are discussing angles theta observed for electrons of kinetic energy E could be fitted Bragg equation if the wavelength were ascribed to these electrons that was defined by this. Okay. Cool. These findings are on the this just electrons over the particles might have some properties described the waves. That is the proof suggested. The electrons seems to have a wavelength inversely related to its momentum. And to display wave-type diffraction, I should mention that analogous diffraction was observed when all small light particles from the neutron nuclei and small atomic ions were scattered from crystal planes. In such planes, observed Bragg equation from some of the scattering angles of one assigns a wavelength to the scattering particle according to this. Okay. Makes sense. 9 nanometers. Okay, alright. Yeah. Yeah, okay, so far everything seems pretty typical quantum mechanics-ish, I would say. Nothing too out of the ordinary. Unless I'm missing something. The other panels show how these lines have been analyzed into patterns that relate to specific energy level photons. Hi there, Krish, welcome. In the early attempt to rationalize the spectra, there was electronics motion, one describing electrons moving about an atomic nuclei and circular orbits figure. Okay. Okay, so these are the early attempts, I see. Hence, why forces this way. So I'm assuming. Becomes more and more negative, and R becomes smaller. Wait, what? Reference of energy at R tends to infinity. Oh no, never mind. My brain just froze for a second. Okay, more coffee. Would love some. So this is like a brief history of quantum mechanics of electrons. Okay. Some kinetic energy and potential energies as this, just like about the function of. And more negative energies. Of course. Okay. I'm not gonna lie, it is certainly a dense read, but this is just introduction to quantum mechanics of electrons. Just execute well. This loud wavelength context to obey this. Okay, yeah, Makes sense. See how my man wish you gayness. I'm sorry. What? Wasn't that something you could wish for someone? Okay. Speed of light is travel waves with high speeds instead of the material using the expression. Okay. Frequency wavelength are related by its so-called dispersion equation. Gee whiz, this is so much. Oh my goodness, it's so much. And so this is just the quantum mechanical background for the rest of the textbook, I'm assuming. Okay. Oh, Schrodinger's equation, alright. Operators, yep, have been there, right. Mm-hmm. Ah, our beloved Q of J. Mm-hmm. It's gonna probably the fact that they are operator access coordinates and this is equivalently. Okay. This is. That's a great equation, I gotta say. Mm-hmm. Written as this, alright. So, agency Hamilton operator. Moreover, using the fact one can show that any operator F formed using the rules described above is also Hermitian. Okay. Got it. Which means Hermitian operators probably will be important later on. It's fine. Dirac notation. Ah, yes. Where these symbols represent sign, okay, putting it together, construct implies the integration of the variables that y depends upon. Oh, that's really convenient. Okay, I see. I see why that would be useful. Oh, this is just so much cleaner than this. Okay, I love it. I absolutely love it. Okay, so left side is okay, so to the left that's conjugate, to the right that's normal. Matrix between pairs of functions, the coordinates can integrate over. For example, the matrix representation of any of an operator f when acting on a set of functions denoted this way is this. Alright. Matrix have the following property. Okay, sweet, sick. This makes sense that they would have this property. Right? That makes sense, does it? I think so. Almost certain, kind of. I mean, we did just see proof, just a bit, you know, it was just a bit tough to follow, let's just say. Okay, no, you're just bringing out the conjugate to the outside from the inside. Okay, that makes sense. Okay. That does make sense. eigenfunctions having eigenvalues respectively, and this multiplying this equation on the left by psi and integrating over the coordinates named by q, that f acts on gives this. This is going to be a breezy read, I can already tell you. What a light read it will be. I don't think this is quite what I'm looking for though. To be fair, this is just the quantum mechanical background. Let me peek ahead. This is advanced theoretical chemistry. Once again, I don't want to make another physics video, though. I don't want to make another physics video. I've had enough physics. To be fair, this will be very heavy on physics. There will be plenty of physics there. Maybe the problem is that I don't know what I want to make a video about. That's maybe the problem. Because now I'm thinking about this, like, this video very much will be about physics. It has to be about physics. The entire point of it is the fact that, you know, electrons, of course, don't behave like a classical mechanical object. They have their own mechanics, which are unique to them. Something that does not have a classical analogy. But at the same time, if you understand these mechanics, then chemistry isn't really chemistry, it's just physics. You just need to understand these mechanics. In which case, this would be just physics. In which case, this would be the same video as this. Huh. Okay. I see. Speaking of my integral rendered, so I suppose we can ponder this question whilst working on the animation. Our area under this function. That's simple enough, just made the area, render the area. So that means I do have to, the only research I can do will be thermodynamics, which, unfortunately, does not make for an entertaining live stream, I can tell you that much. I really shouldn't research thermodynamics on stream, but I really want to. What am I supposed to do at this point? Like, work on the video is the only thing left. Just be working on one video, that's a waste of time. Oh wait, no, we need lower, right? Right here, there we go. And extrude. Why is it? I'm sorry. There, should be flat. I guess these live streams aren't all that entertaining anyway. And if we're going for it... Wait, why am I doing it in straight lines, actually? That's a good question. Oh, that's gonna be... Oh my goodness, why was I doing it in straight lines? There we go. And apparently I messed up bad. Good. That's great news. Okay. Delete the front layer. And sweet. Yeah, integral. So the area under the function in this context. That's what we care about. Under this function. Could you imagine back to a bunch of rectangles right there? Okay, so the reason why I switched to a different... so the reason why I switched this to a simpler equation. So, you know, from the original mess going up and down, some polynomial with however many... I'm sorry, where did I render them? In derivatives? Okay, good. I rendered that in derivatives. Whoops. Whoopsie on me. Integral frames. There we go. Now, the reason why I switched it over to this function instead of the original one is that right now we're gonna need some geometry nodes. Yeah, they are already in proper spot, that's nice. And then geometry nodes. Geometry nodes, which will be an approximation. Not a rectangle, was a cube, right? Cube, like this. I'm pretty certain there are no loops when it comes to geometry nodes, which sucks. Which means we'll need a mesh line, I think. Instance of points. There we go. And then mesh line, we want to go to the right from the left. Yes, so we want it to start at y2. Yeah, whatever, 2 is good enough. And then we want it to go to the right, which means the offset we want to be... For now, let's just do a -1, like this. There, now we have a bunch of rectangles. And for each one, we want to take the location. No. We want to take the position like this, separate it, x, y, z, take the y coordinate. Actually, you know what? For now, just plug into size. Ah, I can't. Okay. Why can I not? Why can I not? Okay, so apparently this doesn't work, right? Instant index. Can I take index of an instance? No? Alright. Maybe for vertices? No, okay. So I can't. Sweet, that's nice, it's whatever. What I'll need instead is the index right here and counter transform size or resize or scale. Okay, this is doing quite literally nothing. Oh! Oh, okay. No, okay, uniform. That's not how I want to rescale it. Up. Uppies, please, if I may. Not the center. We don't care about the center either. Axis, I guess. I'm sorry, what now? What's this axis? No, I meant like scale. Instances. There we go. There we go, that's what I'm looking for. Gee whiz, okay, good. Can I plug in the index like this? Yes, I can. Okay, great. Because that's... Okay, that's gonna save me a bunch of work. Because now we can take position. And hopefully we can set it to scale. Didn't break. That's something. Also right here we have an invisible cylinder. 2 of them in fact. Okay, so it didn't break. That's certainly something. Oh, it's probably because it's 0. Okay, vector math add 1, 1, 1. That's probably why. Okay. Okay, good. Yes. It's changing on the y-axis, which is correct. And so what we want instead is we want to separate this xyz, then combine xyz like this, with x and z being 1, and y being like this. Okay, okay, we're getting somewhere with this. We are certainly getting somewhere. Now what we want is we want to change it up in a way so that it's moving up or down, not scaling. So first of all, put it on the ground, like this. Give me your... What is it called? 0. Oh, I can just set 0. Not you. I can just set you 0. Sweet, lovely. Now we want to change it up so that we are scaling it and then we're moving it up. So set position and then offset it by the exact same thing, except this time with 0, 0, and then math divide by 2 and then absolute value. Okay, we're getting somewhere. Alright, almost there. Now this is giving us the y-coordinate of a normal function right now. Or absolute function, rather. But what we need instead is... a different function. I am good at this. What the function that we need is... if I do remember correctly... E, so right here we're gonna need to plug in. Can I just do E? I love Blender so much. E to the power of negative x squared. E to the power of negative. I am good at this. Oh, I'm good at this. Yeah, and then all of it just times 2. Oh, I am phenomenal at this. Hell yeah, that took me way less time than I was expecting it to, I'll be honest. To be fair, we did not place it the correct height last time. Hi, Animal 1000. Oh, I am so amazing. Okay, cool. Now, the only thing to fix will be to move them tiny little bit to the right. Okay, so now we need to left right it, fix it up. So, first of all, we would like an index which will tell us how many we have. So each time we extend them, this is adding more squares. That's not something we want. E is an amazing number. It really is an amazing number. I'm finally glad that Euler got a constant named after him. You know, that guy deserves some recognition. So undervalued. Okay. So what we need is we need to push it a little bit to the right. By half the width of the rectangle. Also, this would be appropriate for 5. So this is the width we want with 5 cubes. No, we want to move it a little bit. It's difficult. 6. Then move it right here. Half the size of the rectangle to the right. Which means we're gonna need a math node. Okay, so what we want is we want the, correct me if I'm wrong, we want the width of this divided by the number of rectangles. Should be an inch 6. Okay, there we go. Now as we add in more, they are disappearing. That's good, that's correct. Makes sense that, oh, it's 6 divided... I'm such an idiot, of course, okay. Alright, yes. Now, we also want to plug it into position, except divided by 2. And the reason why we want to divide by 2 is because we want to divide by -2, actually. Might be the right one. Yeah. There we go. Except now they start too late, which means we also want this to start at 3. I am so good at this. And now as we add in more, there we go. As we add in more, we also want to shorten the distance in the offset, which could actually be the same number. It could be the same number. The only difference is we need to multiply it by -1. If I manage to get this right in the first try, that would be seriously impressive. I am amazing. I just want to say, I don't feel like enough people appreciate just how amazing I truly am. You know, I don't think it gets said nearly enough. Just how absolutely amazing I am at times. There we go! Yeah, it is a bit off. That's mainly because, well, on the right it makes sense. That's where we shifted. But on the left it's a bit off because this isn't exact science either. But now what we want to do is decrease it in size right here. Till it's a tad more flat. And then one last thing, set material to color bright. Oh yeah, who needs manim, am I right? When you get when you can get this. It is one of the offset, but as I mentioned, that's mainly because of our NURBS path not being ideal. We can subdivide it further, and then you can see, right, just how messed up it truly is. Can I add a modifier of like subdivision surface? I cannot apply subdivision surface and NERFs. That does make sense. Hi, Zavaroje, welcome. Hi, welcome. We might need to render this again, but this time we do have an exact point to which we want to bring down our things. Or actually we could just add in more. Yeah, actually we could just add in more of these. Just feel a bit cheap to just like do it manually, but unfortunately, you don't have the access to the same tools. The curves for some reason. For some reason, those tools are only for meshes. There we go. Now the only problem is the fact that these are absolutely not keyframed, and we need to keyframe them, and we need to hope they don't break. They broke. Ah, fudge! Fudge! They absolutely did break. Ah. Okay, how to fix it? Great question, no idea. Well, I have one idea. I can just Control Z until before we made any changes. Like this. Now this looks like the original animation. Yeah, this looks pretty much right, correct? Let's see. Yeah, okay, this looks correct. And so before we made any changes, then go in here and just subdivide all of them. Can I subdivide them somehow without changing the curve, or is that like a no? I guess I could just save it as a new one, and then right here just do another animation. Smooth. Left room and some. It's integral. I'm just basic stuff. I'm not going into just basic stuffs. This really looks a bit better. Okay, let's copy it. We'll use that as a reference. It's so funny how I set up the geometry nodes perfectly, like mathematically perfectly. Geometry nodes in the background are mathematically perfect. And I'm just fixing the curves manually. There we go. Insert keyframe. That will be our keyframe from now on. And now right here, what we want is... we want it to fit exactly. That's what we're gonna do. Give me some more. There we go. Now we can actually try. Hell yeah. Has to be on the exact tips. Like this. And like this. And like this. There we go. Oh, not even difficult. Not even difficult in the slightest. Now I just need to turn this off and render another animation. Another fix-up animation. This time in the integrals. There we go. Cool. That was really easy, actually. That was surprisingly not difficult. Now. I'm still I feel like I'm so indecisive. Can't pick a textbook even. General chemistry. Shouldn't be general chemistry. No, it won't be general chemistry. There's no way. Oh, maybe. Ooh, could be maybe. Could be maybe, probably, perchance. Or maybe advanced chemistry. Maybe I'm just thinking about this wrong. Maybe chemistry is just physics. I should leave it as it is, and then go back for the advanced chemistry is easier video. Advanced chemistry is easier, and just change it up. Change it from something like. Change it like from a video, like a typical make it video where we start at a certain level of abstraction and we either go down or go up, into just like a fun video about like fun facts, why certain things exist. For example, states of matter, why they exist, why chemical reactions happen. Why can't I just make a fun light video with no like deeper meaning? So you know, stuff like why chemical reactions happen, or states of matter. What's the deal with states of matter? Or like freaking stuff and junk, like why do I only have two? Come on, there has to be more than two. Different parts of atom? No. Maybe? Perchance. Perhaps. No. Rather not. Maybe. God damn it. Yeah. I feel like 5 is, or 4 at the very least. So then something fourth and then conclusion, because we always need a conclusion, of course. How would I ever be able to make a video without a conclusion chapter? I don't have it in me. I always need a conclusion chapter. Otherwise, I've been cursed by a witch long time ago for practicing wizardry, and ever since then I've just been trying to regain my strength, trying to repair my crystal stuff that's been scattered throughout time and space. And until I do, I am cursed to always add a conclusion chapter at the end of my videos. That's a fun little story from back in my youth. Alright, so why chemical reactions happen would be a banger, and I absolutely love it. Why do chemical reactions happen? Yeah. All seen plenty. Actually, with this one, I feel like I should divide it in between. I should do something I haven't done in a while. Because yeah, for this one, I can do it without almost any research, because I've been talking about energy for such a long time. This one we will need some research, but it won't be difficult. This one won't require that much research. Something fourth, I'll have to ask Flame. I'll ask Flame if there's anything. Oh, this could be... Oh, maybe light and matter? That would be a pretty cool one, like why light affects matter and light, heat and matter. that would be that would be a pretty cool chapter. I feel like that would be fun. I could ask Flame about it and all, but I won't ask him now because it's gosh darn middle of the night for him. Okay. Actions looking like this, all this, all this, and all the different rules. Pi bonds, the electronegativities, the oxidation states, and so on and so forth. Now the reason why, actually not pi bonds, the acidity. The reason why I want to mention acidity, electronegativity, and oxidation states is because all of them are, at the end of the day, extremely abstract concepts, which, when it comes to like theoretical chemistry, I don't know what to call it, like the understanding of the atoms, all of them are kind of irrelevant. As in, that, like, if you are building a ship, then acidity, electronegativity, oxidation state is more like properties of the ship rather than the structure, the build, the working out, and so on. I don't know if I'm making any sense. That was an awful analogy. I will need something better. But why do happen? We start with oxygen and oxygen gas. Then it, why does it turn into water? We'll have to start with the electron. And right here, this will basically be like a bit of a little cheeky little bit of a little recap from the electron video, you know. This is about the electrons and whatnot. Tomorrow I'll really have to stream when Flame is awake. This is looking good. By the way, hold on, I know I'm getting distracted, but that's mainly because I'm over caffeinated, okay? Not much I can do about that. I wanted to turn this page off, but I've grown attached to it. Okay. Area on this function. Okay, imagine a bunch of rectangles like this. The area. Oh, we can render the area using. Oh my goodness, we can render the area using the geometry nodes we already set up. That's comical. So this side of any single rectangle being equal to, actually no, I like this more. The area of the rectangle which we could get using multiplication. So this side and this side. The reason why I say using multiplication is because it's a little wink wink nudge nudge to the first chapter. The atom. We have really charged protons, negative negatrons, electrons. I do want to do a bit of a bit like with the photon, you know. So carry a particle of gravity is graviton, and carry a particle of electromagnetism is electrophoton. I like that, but it's funny. Negative electrons. center, the nucleus, we have the positive protons and neutrons. Center is positive. Oh, that it is. Okay. There, sweet, rendered. Why is this spike so big in the middle? It looks a bit wrong. Oh, what do I know? And now we can actually render the area using our geometry nodes. Oh, this is phenomenal. I love it. I love it so much. Oh, we've set up geometry nodes in such an accurate way. We can just use them to render. Oh, this is great. I am proud. Oh, I'm proud of my boy for doing such lovely renders. I don't know. I'm in a really good mood today, I gotta say. Recently, I've been feeling like shit. But then at some point, I just woke up and I was like, hey, make it. Why are you feeling like shit? And then I realized, oh yeah, I'm not gonna be productive if I'm feeling like shit. So I just stopped feeling like shit and like... Oh, it just worked out for me. Okay, then we go into the script, which is this one. A bunch of rectangles like this. The area of features. Okay, so like 7 rectangles. Too few. Oh, that's also a good one. I like that a lot. We can start with 1, and then at 90 we can do 30, 31. There we go. And then it will just like slowly get more accurate. Oh, I like it a lot. Okay. Cheers to the geometry nodes I've made. They're pretty lovely. An electron cloud. Nucleus. No. The middle of atom have like a positive. Hi, the jam salad. Welcome. Hi. I haven't seen you in a while. Hi. We have a so something. Oh, good. Holiday in the US. Oh, on holiday in the US. Been missing the streams. Ah, fine. Don't worry about it. I do stream literally every day. Plus, the recent couple of streams were, whoa, this has still motion blur. I didn't think of that. I forgot that this would have motion blur. Okay, it's pretty cool actually that Blender can make motion blur for this, because that is actually pretty cool, the fact that Blender can add motion blur to something as complex as this. Do you think you will miss a day? I mean, I haven't missed yet, so... I'm pretty certain there's like a solid probability method to check. You just take the amount of days we had so far, and I mean, one approximation, I've seen Ruby on Brown, so I might be butchering it out of context, but it would be 612. No, wait. So assume that 1/612s. I'm done with probability doing statistical mechanics. I'm done. Miss a day. Will you reset the days or keep it going? I will reset, of course. Oh no, I'll be done with the streams. That's it. Well, okay, maybe not done. I just wouldn't be streaming every single day then. I haven't missed a day yet, so. Yeah. Oh, you got me thinking about like how much time I've spent streaming and junk. You should make a video about E. About as in the constant, the Euler's constant. I don't know. It's pretty simple. It's just the limit. Explained. What was uses though? It's so fascinating. I mean, okay, its uses. I feel like pi kind of takes the spot there when it comes to transcendentals. Although I do, yeah, E is found quite a lot. It's basically the number of limits to infinity as something converges on something. That's basically the usage of E, as far as I'm aware. So if you want, so basically, almost always when something is converging on something, when approaching infinity, you can somehow relate that to E in some way, shape, or form. Although Euler did link it to a bunch of wild stuff. Of all important constants and natural occurrences. That's not the worst idea, actually. That's a maybe. Pi E golden ratio. And the reason why they exist. That's a maybe. Heck, I'll add the list. No, that's the wrong one. A list of videos that we can make right here. Math. Pi E golden ratio, etc. Why are you constantly stupid? that's a good one. Oh damn it, it is a pun, isn't it? Ah. Why are they constantly appearing? No, wait, why transcendental? I need a double pun there because I can't just steal I can't just steal yours. I need a double pun. Avenue of Something. Okay, yeah. Why are they constantly appearing is a good one. Oh, that is a really good one. It's a video of constants. I love it. Oh, that's a really good idea, Ram. I gotta say. All right, there. Add it to the consider it added to the list of videos that I have to make. That's so many videos. It seems simple, and it is extremely. Inside the shower when made. You know what? Actually, that is true. I'm gonna add, just in case, my goldfish dum brain. Where to forget? I'm gonna add it right here. Jam salad, the sequel. The. It's actually pretty rare that someone suggests me a video I should make, which I actually end up making. Because most of the time people suggest things which are very much, well, would be interesting, but not for my channel. Quantum computing being, I don't know why so many people want me to make a video of quantum computers. I've never even made a video, well, I have made a video of computers, haven't I? Like a basic one. I'm on Jamsalad 2 because Jamsalad was taken. Hey, sequels are sometimes better than the original. Sip. Ah, stale water, delicious. Mmm. Less energy. I thought Matrix 3 was going to 1. 2 was us. I mean, yeah, the third one. Okay, to be fair, the third one, you know, that was the end of the trilogy. So, like, of course, it's going to be way grander, right? The final scene, of course. It's absolutely massive. No sacrifice was great. But I don't know, I like the first one. Second one, I don't even remember what happened in the second one. Second one felt more like second half of the first one and first half of the third one, honestly. I don't remember how the second one ended, or was it Neo saving... Oh, was it when Neo was flying to the city? Was that from the second one? I barely remember the second one. Oh, the fourth one came out too. I haven't seen it yet. Cause why would I? I have to rewatch Lord of the Rings. Oh, I do it every now and then. It's great. It's such a nice thing to watch. Oh, Hobbit, actually. I really like The Hobbit. I know, I feel like Lord of the Rings is too much of a classic for me to enjoy it anymore. I like a Lord of the Rings. I remember seeing it. It's pretty cool, but this one is too much of a classic. Like, I already know it really well, but Lord of the Rings still has that novelty vibe. Speaking of flights, fix the gun of flight prices and logistics. Oh, you mean... yeah. Yeah. Capitalism, brought to you by rich people. Well, actually, capitalistic greed, rather, of rich people. There's nothing I can radicalize a guy quite as, like, taking an intercontinental flight. The problem with flights is that it's a natural monopoly. Well, a semi-ish natural monopoly. And the way it was also... national flights cost so much. Yeah, the thing is... There's actually history of aviation in the US, or rather the flying industry, is really quite curious, but basically because of a real unfortunate chain of events, all of the companies there that, you know, took care of flights and whatnot were originally extremely and heavily regulated. Then they went through a phase of deregulation, then they went through a phase of deregulation and subsidies, and then they basically, the big boys killed off all the little boys. So right now we have a couple of big boys with a monopoly. And so you basically... and so the reason why they suck so much is because, you know, they don't need to try. Like, you can either fly in awful conditions, or you can just suck it and not fly at all. It's a monopoly at this point. Or a cartel, a bit more. That's why it sucks so much. Okay, right here, what we need right now is we need to copy this, we need to apply it. Oh yeah, we can't apply it, that makes sense, because right here in geometry nodes we need to realize them bad boys. And now we can just... they have all those different current to services and all different prices, but the companies are based on the same lot, all use the same cars. I agree. Watching all the same companies use the same cars and charge different prices. You know, it's the brand of rental cars that they don't even know. It's so silly, actually. Okay, now I'm gonna need you to zoom in like this, to the side like this, and you This is not gonna be the easiest one to make. Design not keyframe, damn it! Yeah, from they're not even hiding it. I mean, if it works, I guess. It is a bit funny though. The idea of charging different prices for not like the exact same service, not like for the exact same model of a car, the exact same car. That is pretty funny. There we go. And now this. Look, everything in the store is on sale, and there's a couple of items that are going but soon. Every single item has sale as well. Actually, okay, that's not all that crazy. Jam, where are you from? Because in Poland currently there are a couple of stores which have crazy lot of sales. I take advantage of one of them. Like, for example, right here you can hear, I don't know if you can hear it, but this is my yogurt. It's yogurt which I buy every couple of days. This was from Switzerland. I see. Oh yeah, I do remember it. Okay, never mind. You mentioned that before. I'm so sorry for forgetting. But you can hear a yogurt, right? In Poland, there's currently a shop, really famous one, where I go to buy them yogurts. And every single time I go there, they are on sale, where if you buy 3, the 4th one is... If you buy 3 of them, the 4th one is also free. Funny enough. And so that's why I eat such a crap ton of them. And so I would say that's pretty normal, actually. It's actually really nice because you can go to a store and then you get a very varied diet. But the reason why it's varied is not because, you know, you're trying to make it a varied diet, only because each time different things are for sale. It's really convenient, I gotta say. This side times this side, so each rectangle is equal to the coordinate of the function. Function plug into the function. Now what the width? We don't know exactly what do. Let's say difference in x or dx for short. Some other regions say Switzerland, but the US now can everything runs the point of a sale. I mean, if every item is for sale, then yeah, I guess that's that's not really a sale. That's like that's just called selling stuff. Unless they mean like on sale, as in, you know, as in you can buy it. As in they're selling it. Unless that's what they mean by, you know, on sale. Well, this time you can actually buy this carton of milk. Or bag of milk if you're from the unreasonable part of the US. Not the US, only America. Okay. I can do so many of these using geometry nodes. Oh my goodness, that's good. That's good. Almost that. This integral chapter is so short too. To be fair, they are pretty simple. Like $6 for $2 of chips, and we'll say $2 for 4. Motors at sale. Every item in the whole aisle will have the sale. Actually, okay, to be fair, there is like one thing which I don't really like when shops do that, where basically they put an item on sale even though it's absolutely not on sale. That happens a lot. France, near where I live, there is a bakery which has one sale, which is buy 3 baguettes, get 1 free, which is good because it can endorse good value, but not every single item is on sale to try to scam. Yeah, precisely. Like, yeah, there is the practice of basically increasing the price of an item and then adding a sale to bring it back to the original or a bit higher, and then people buy it because it's on sale, even though it's more expensive. That practice is just a scam, which, yeah, that sucks. That's why in the shop that I buy it, actually, one thing which I did, which is I really love, is basically whenever they give you a sale, they give you like, hold on, this is because I actually really like that. So the way they do it is each time you have an on sale sign, you have the price of the item, so just say $2.99. Then you have the terms of the sales, like, you know, buy 3 items and the third one is 40% cheaper or something like that. And then they give you the price per item if the discount applies. Which means that if I go to the shops, if I want to buy 4 yogurts, right, then I can just take a look at this and treat it as if it's not on sale anymore, which I absolutely love because it removes that scam part. W Poland Market indeed. Although, to be fair, this happened because there's a whole like storyline there about how 2 different markets in Poland basically are in extreme competition. I think it was Lidl. I think it was Lidl, I think. It was Lidl. Okay, yes. Basically, there's like 2 shops went to all-out war, where the first shop, all of its ads were basically, we're cheaper than the second shop, and the second shop was like, our prices are lower than the first shop. And all of their ads, like all of their campaigns, were basically about trying to have lower prices than the other one. And damn, it lowered down the prices like crazy. It was good. I like that. I like that a lot. Shells, sub-shells, orbitals, and so on. Everything is so overpriced. I'm just lucky to live on the border of France and Germany, so I can stop there where everything is half price. I mean, to be fair, you do live in the most expensive country in Europe. Actually, let's check. Cost of living, I do believe. That was the website. Livingcost.org. I love this website. 2.9k. Yup, you do live in the most expensive country in Europe. And the 4th most expensive country in the world, so... You're actually one of the few countries, or you live in one of the few countries where you can go to the US, and that's like... lowers your cost of living. wages are super high, so it's still balanced. I know, actually. I like countries with the high cost of living usually are the wealthier ones. That's why, you know, in the top 20 you will find US, Switzerland, Ireland, United Kingdom, Luxembourg, I suppose, Netherlands, Norway, Denmark, Canada. Like, these are still the rich ones. I am all the way down here on the 60th place. And then even lower you go. Russia on 143. Yeah. Lower it goes, the worse it gets. All I know about Switzerland, well, I know a lot about Switzerland, but the thing that's most notable for me, because living in Switzerland, is I've heard really good things about your public transport. Apparently it's incredible. And I used to live in the US, and it is cheaper to live in Switzerland because you have less stuff. The reason part driving is so much less important. Precisely what I mean, right? Like, in the US, public transport is non-existent. Not owning a car is... I don't own a car. I don't have a car. That would be an insane thing for any sane American. I don't live in a big city and I don't own a car. And I can live like that because public transport exists and it's really good and I really like public transport. It saves me so much money. Oh my goodness. And Switzerland is probably the country of the best public transport in Europe, which says a lot. Actually, country of the best public transport in Europe could be also the country of the best public transport in general, maybe if not for Japan. Sounds like great where I live. They are everywhere, but it's super slow. I mean, yeah, but they are everywhere. This is incredible. You can get anywhere. It takes me 40 minutes to go 6 kilometers. Okay, 40 minutes per... Okay, I see what you mean. That's 10 minutes, 1.5 kilometer a minute per... 1500 meters? No, 150 meters. It's not quick. That's 2 meters a second a bit, right? No, wait. A minute... Yeah, it's 2.5 meters per second on average. It's not quick. That's like walking speed. You get what I mean? Yeah, I get what you mean. Still, in most cases, I would say it balance each other out. Like, the further the distance, the quicker you go, right? So if you want a really short distance, you take a tram. But if you want a really far distance, then you get a train. So the further the distance, the quicker your average speed will be. And so considering that, you know, normally if you needed a car, like if you needed a car, you still need to account for the parking time, for the getting out time, for the traffic, and so on and so forth. I would say that, in my opinion, trams are still better. Also, trains go everywhere. That's the second thing. Not just bikes. I know we've seen Not Just Bikes video. Did I mention that before? I feel like we had this conversation before. I just really like public transportation. I take an actual train instead of tram. That's insane. I love trains. I believe Not Just Bikes went to Switzerland just to make a video about trains and trams. And oh my goodness, he was impressed as someone who lives in the Netherlands. Country that's famous for, like, just public stuff in general. It's incredible. Your bike was stolen. Ah. That's mean. Why would anyone steal a bike? I don't... In a country like Switzerland, what? Hi there, Gabriel. Welcome. I'm so glad you could join us with your famous catchphrase. Why would someone steal a bike in Switzerland? That's so wild. Resell it? Switzerland? I don't know. Just insane. In my opinion. It's like the only crime here. By the way, it's 6 AM. Why? Because we rise and we grind, you see. We rise and we grind at the break of dawn. There are videos to make, there's research to be done, there are animations to render, there are geometries to node. Get some sleep. I'm gonna get my sleep when I'm finished, okay? Oh, yummy. He's on winter arc. True story, actually, funny enough. For some weird reason, winter screws up my entire lifestyle. In a way which has nothing to do with winter itself. Basically, for some reason, every year when winter comes, I just get so much more, like, brooding and fuck it we bullish than the rest of the year. I love winter. I love winter too. I don't know why it screws me up like that. I actually love every season. If I had to rank them, it would be autumn, winter, summer, spring. But I won't tell you if it's best to worst or worst to best. Summer, no, but okay, hating summer is a bit much. Like summer is hot, but when you're hanging out with friends, summer is just amazing. Okay, here's the thing. Here's. Hot summer. Okay, yeah, too hot summer, I get that. Yeah. If I had to choose between extremely cold winter or extremely hot summer, I would rather pick extremely cold winter. But at the same time, summer in general, where was I supposed to? I was trying to open something. Oh yeah, I remember what I was trying to open. There we go. Summer in general is. Do you have AC? I do not. I don't need AC. I don't get much sunlight, so I don't get much sunlight, so I don't really need AC. You see. It's illegal in Switzerland to have an AC. I guess that makes sense. Climate change, I think, and stuff. I always put more days if I can't take your skin off. I mean, you can take your skin off if you have got the dedication. Exactly. It's all about the mindset, the mentality, you know. Don't say I can't take my skin off, only say I haven't taken my skin off yet, but I will. Growth mindset, or rather shrink mindset, because you know you're actually taking it. You get it. I'm looking for a. This note. No, that's different. I'm looking for a document, my research document. Problem is, all of them are just called random things. Why are all of my research documents just like called either untitled document or just random letters or untitled document? Is it a research one? Oh my goodness. Yeah, just about times and it's bedtime. See you next time. Bye, Jamsalt. Bye. Where the satisfaction grind make it? I don't know. There was no like. I don't know. No one seemed to care. Is it this one? No, it can't be this one. Can it? It might be this one. No. No, yeah, there we go. I think it's this one. Evening, alright. Wait. Ah, damn it, I can't find the freaking document. No, I give up. Well, spin is just a thing that electrons have. It was up and down, right? Hold on, electron spin. Stop my dinner, so I'm very sorry, but we'll have to leave you on your own thoughts. Oh, don't worry about it. I actually might end the stream too. You know what, everyone's leaving. I did start the stream at extremely awkward times, that's on me. I probably should. So you know what? Fine. Solidarity. I'm going with y'all. For now, I suppose. That'll be it. Thank you everyone so much for watching, and have a great day. Bye.